Okay, so in this video today, I know it's been a while since I posted anything. I've been busy with those SEA students and just had to take a break. So we're going to talk about limits today. So limits, Limits. So limits is the precursor to integration and differentiation. Even though in AdMath it's not on the syllabus, it's actually the precursor to integration and differentiation. So when I reach the part where I'm discussing something called the limit theorems, for those of you all who are familiar with calculus, that's integration and differentiation, these theorems gonna look hauntingly familiar. But before we get to that, let's look at the concept of a limit. So the concept of a limit is something I find is something rather easy to understand. So let's go. We have a Cartesian plane there, and let's see, we have some function. Now, it doesn't matter what the function is here. I just throw in any random function. So let's pick some x values. Alright, so call it x1, call it x2, call it x3. So we know from normal math, we could do something called direct substitution, which is we could substitute whatever these x values are and get a corresponding y value as, okay, that's not symmetrical. We get a corresponding y value, so we get some y, or we could say f of x1 because this would give you the y value when you input it into the function. So we say this function is f of x. Some random function, doesn't matter what it is, just to illustrate the concept. And here would be given by, I know I missed the color, but good enough. X2, yeah, is f of x3. So we know from normal math and previous knowledge that we could get corresponding y values. All this is y values. We call this y1, y2, y3. And from normal math, we could, draw the table or the mapping diagram, whatever you want to do, and say x1, x2, x3, and we get the corresponding y1, y2, y3. See, from normal math and knowledge from before, you could draw it in the mapping diagram form too to show the coordinate pairs or the pairs of values. But keeping that in mind, let's erase some stuff here. This would be so fun to do. Keeping that in mind. Okay, alright, how to clear this? Done. Right. Alright. So have a Cartesian plane. Have a Cartesian plane, some random function again. So let's say we pick a x value. Call it we call it E. I have a reason why I label it E. So we have x is equals to E here. And well, we know if we substitute this, we will get a corresponding y value here, right? But we are gonna do that now. What we're interested in here is taking x values to the left of E. So like all these values here is allowed, any value, and to the right of E, right? So we could put to the left of A and to the right of A. And we could say x1, x2, x3, x4, x5, dot dot dot. So here's x1, x2, x3, dot dot dot. And let's just call the values to the right of, let's just call here b, b1, b2, b3, b4. So all these is x values. So b1, b2, b3, b4, b5, dot 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 dot. So it's just you think of a number line because the x and y axis are number lines, and you're just picking values to the left and to the right. And similarly, you draw a corresponding table and you f of your left values and f of your right values. And you would get corresponding all these as y values here. You will get y values all here. So here we'll get y values to the, when the x is to the, let's see. So let's say, see, one is to the right, you will get y values above the suspected value here, because we are assuming we don't know this value here. We don't know about direct substitution, which is just to plug in and get the value. So we get some value here, and if you pick it to the left, you will get some value like over here. Oh, not exactly, but again, all these videos it's be coming from my head. I just think about what I want to do and just do it. Yeah, so these corresponding values, you will get y values here. And as we get closer and closer to our a value, like we pick values like real close to like here and here when a was here. It's like real close. As we get closer and closer, what we would see is that the y values that corresponds to the x values chosen from the right, and the y values that corresponds to the x values chosen from the left here. So here's to the left, here's to the left, here's the f of the left values, f of the left values, and here's to the right, so f of the r values, f of the r values, and here's to the right. It would approach a certain value, and when it approaches a certain value, we see that this value here, where if we did just substitute x and get a corresponding value, we call this the limit. The limit is just a y value. It's technically just a y value on the y-axis based on a particular point chosen on the x. What I mean by that is that I just choose this as a here, right? But let's say I choose a here. Let's say I had a there. Then, well, here would have been the right, here would have been the left, dot 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 dot, all this would have correspond, like this would have be a left value that correspond, here would have be a right value, and the value L would have drop a little bit here, so it'll drop to like somewhere here. That's what a limit is. It's basically you want to investigate the behavior of a function around a certain point. So I'm gonna unclutter this. Draw back a Cartesian plane. of a random function. So you want to investigate the behavior of a function at a given point E. That's what our limit is. The y value, we call it L when we talk about limit. And we approach from the right and from the left. When we approach it from the right, we say x plus, and here's x minus. This means right and left respectively. The plus is like to the right, the left is to the left. Sorry, the minus is to the left. So we see when the limit as x approaches the point okay, here's supposed to be a minus and here's supposed to be a plus. Yeah. Remember, here's just an x value. Here's just some x value. So x is equals to a. So we see the limit as x approaches a from the left of the function f of x. Here's the function f of x is equals to the limit as x approaches a from the right of f of x. When the left hand limit is equal to the right hand limit, then we see the limit as x approaches the value a of f of x is equals to L. This is the this is an introductory definition for a limit here. It's not the definition, but it's the definition at this level. This is what the limit is. Like, it's just choosing a value on the x-axis. This thing here, this is how you interpret how I explained it before. You choose a value on the x-axis. So step 1, choose a x value. Pick values to left and right. And 3, you find corresponding y values to chosen x values. And if the right hand side values is approaching the left hand side values, then we say the limit exists. So we say the limit as x approaches a of the function is equals to L. Yeah, that's it for the introduction of limits. We will look at the limit terms in our other video.